Welcome back to First Python Notebook. This is Ben Welsh, broadcasting live from Manhattan, USA. In our last chapter, we got to the exciting moment where we actually finished our analysis, put together our two different data sets, tidied everything up, made sure everything matched, and calculated a statistic that we might consider even putting in the newspaper. Pretty exciting. But we're not quite done yet. We put those numbers together and we were able to see what was there, but you can see that the result was actually sorted alphabetically. What we have here is not a ranking of the deadliest helicopters. What we have here is a list of helicopters with their accident rates. To change something from a list into a ranking, we have to sort it using our data values. And sorting is another one of the really basic fundamentals of working with data that is really crucial to learn. It sounds really simple, but it's also very, very powerful. And oftentimes it provides the answers to some of your most crucial journalistic questions. Which record came first? Which record came last? Which record has the most? Which record has the least? And anytime you have a question that kind of has that structure, a sort is going to help you get there. Now, our data set is small enough, this might be something you feel like you can do with your eyes, but think about if you had to pass along your results to your fellow reporter, or if they asked you, well, who finished second and third in the ranking? You know what I mean? You would want to be able to polish up and present to your coworkers and ultimately your audience a sorted ranking or list, right? And so we're going to learn how to do that using pandas and a method it has called sort values. So if we take our data frame, merged underscore list, and we hit dot to again access the tool belt of all pandas cool tools, there is one that just happens to be called sort underscore values. Again, this has an underscore between the two words. Group by did not. I can't tell you why. It's just one of the quirks of how pandas was put together, and you got to get used to it. You know, you might think if you're an editor like me who prefers concision, couldn't it have just been called sort? Yes, it could, but it wasn't, because the people who made pandas decided to call it sort values. I'm sure they had a reason. I don't know what it is. And so into sort values, you can pass any of the fields on your table, and it will resort the data frame to appear according to what it finds there. So if I type in the column we just created per 100K hours and pass that into the parenthesis to that function as our input, it's going to print out our data table resorted using that column. Boom. That's all it takes to do a sort. Now, we look at this, we see an instant problem. It actually sorts from lowest to highest. So we don't have here a ranking of the helicopters with the highest accident rate. We have the reverse. We have the helicopters with the lowest accident rate. Which way to sort the data just depends on what question you're asking. Ascending is what the computer programming systems usually call something that goes from lowest to highest. And that typically is the default, but it can really vary depending on what computer programming system you're using. So anytime you do a sort and you're translating your question from English into Python or on another computer system, you have to think, am I sorting from highest to lowest or lowest to highest? And in the language of computers, that often is referred to as ascending is lowest to highest, and descending is highest to lowest. It's just how they set up the computers. Don't blame me. And so the way that you configure this within sort values, and this is a very strange pandas thing, is you pass it an extra argument, the word ascending. This follows the name of your field and a comma, and then you say false. And so in Python, we saw this earlier, when something is true or false, it's either an uppercase false or an uppercase true. And so as strange as it may feel, and as poorly articulated as the Python code is, what this is really saying is sort it by this column and don't make it ascending, aka make it descending. So this is like a double negative or something where we're saying the ascending option is false, aka I want it descending. Pretty weird. So then I hit play and boom, you see the whole table flip from top to bottom. And hey, looks like our story checks out. The Robinson R-44 helicopter with 38 accidents in about 2.3 million flight hours has far and away the highest accident rate of any of the major manufacturers. And you can see its 1.6 per 100K rate is significantly higher than the second place finisher. right? And much, much, much higher than some of the more popular helicopters that have even more flight hours than they do, right? So while the Robinson did have a lot of flight hours, it still actually had fewer flight hours than some other manufacturers, including another Robinson here or this Bell down here. And so what we find after looking at the rates is that the number of flight hours in the air and the popularity of this model does not really explain why it has more accidents than the rest, right? Because of the significantly higher rate. Now, before we ended up publishing the story, we took these findings, as well as all of my computer code I revealed to the creators of the Robinson R44, and we had an extended back and forth where my methods were reviewed and we discussed the issues. One potential explanation that was raised by the head of Robinson is that this flight hours estimate, which remember comes from an FAA survey, is an undercount, right? So in his telling, the survey is a well-intentioned effort to try to estimate how many flight hours the helicopters spend in the air, but it undercounts how many Robinsons are really out there in the world, and that if the true number of flight hours was known, this rate would come down. That was one of several explanations we were given for why this number was so large. So what we did at that point is I asked Kurt Robinson, who runs the company, well, what do you think is the right flight hours estimate? We let him name a number. And he came back with what he thought was his best guess. And I reran this entire analysis with a few substitutions along the way to put his number in this value rather than the FAA's number, right? And giving him the benefit of the doubt, calculating the number from his point of view, how do they rank? And you can see it if you look at my real life notebook, and we included this fact in the story in an effort to try to bend over backwards to be fair and transparent. And what we found is it still had the highest rate, even after substituting in a higher flight hours number. That was our finding for what it's worth. You can see a lot more about that if you look at my real life notebooks. So, hey, so there you go. With that, you've created a list, and you have here something that might be ready to pass on to your colleagues in the graphics department or your fellow reporters as a sort of provisional finding that we're ready to turn into some charts, and we're maybe ready to start writing some paragraphs to put into our piece. And so I'm going to save the result of this sort in a new variable I'm going to call ranked list. And so we're going to say ranked list equals merged list after the sort. And I encourage you to do the same. Now that we've done that, we're ready for our next section, which is where I'm going to teach you how to take this table and how to write it out to a file on your computer so that you're able to share it with your colleagues and begin to bring other people into the process. See you there.